All right, what's up, everybody? Welcome to the Statistics Garage. It's time to compare some distributions. Let's jump right in. So in class lately, we've been focusing on, or talking a lot about describing a distribution, right? Describing a distribution of data given a histogram, maybe a box plot, maybe a stem plot, maybe a data set, we got it, whatever. So today, we want to start to look at comparing distributions. Just kind of take all that described stuff, just take it one step a little bit further, a little more writing for us. So we're going to jump right in with a free response from 2012, a kind of oldie but still goodie. So here we go. Here's our context. Independent random samples of 500 households were taken from a large metropolitan area in the United States for the years 1950 and 2000. Histograms of household size, the number of people in a household for the years 1950 and 2000, are shown below. So our challenge is to compare the distributions of household size in the metropolitan area for the years 1950 and 2000. So this is our task. Now, before we even start to worry about the compare elements, let's take a second. So a good strategy on any free response, whether quiz, testing, class, or on the exam, is kind of read through once to get yourself a little bit familiar with the context. If there were parts A, B, and C, I would recommend reading through those as well to just familiarize yourself with the question. And then I like to go back and kind of reread everything, starting to identify the key information, the relevant information that I need. So maybe right now you pause the video and start to think about what are some things that you might underline or circle, some things that are going to be useful to us, some information that's useful to us as we move forward trying to compare these distributions. And now you've unpaused the video, and hopefully as we read through this, so we've got independent random samples of 500 households. So samples of 500 households, that's important, right? So that, we've got our sample size. So the sample size for both 1950, what am I doing? Why am I not using this tablet? The sample sizes for both 1950 and 2000 are 500, right? So that's important. Now, just so you know, a little other tidbit for you. Right now, kind of in the beginning of statistics here, we're not too concerned with this independent random samples element. But when we move forward and we start to look at hypothesis tests and confidence intervals in the second semester, this is going to be important information. So not now, but eventually. Our samples are taken from a large metropolitan area in the US. For the sake of this question, again, right? This is just kind of familiarizing us with the context, but as we start to think about data collection, we always want to be aware of what population our sample represents, right? What larger group are we representing with these two sample histograms? And in this case, it's some large metropolitan area, but it's not like the whole country or the whole world, right? It's specific to this metropolitan area. One thing I do think is important, because, we got to know what we're writing about. So we're looking at histograms of household size, right, which is defined as the number of people in a household. So kind of building off this idea as household size is the number of people in a household. When we look down at our histograms here, kind of soaking these in, right, analyzing, looking at what our labels are, just kind of getting an idea of what this is showing us, we start to notice that these bins are centered, right? So this bin is centered over 12, or this bin right here, this is centered over 1, and so on and so forth. And so we should recognize that the fact that that bin is centered tells us that this one or two households, these 1 or 2 households had exactly 12 people in them, right? So we're not looking at an interval. This one household right here had, these 60 households right here have exactly 1 person in them. So we can determine the exact minimum and maximum, right? That's what I've done in purple here for the 2000 histogram for each graph. Right, we're not looking at intervals. We're not looking at bins that are like between 2 numbers, right? You're not gonna have between 5 and 6 people in your household, probably. So that's kind of getting our heads wrapped around the information we're given and the graphs we're given. So as we start to think about comparing distributions, when we're gonna compare distributions, we're gonna comment on the same characteristics we would comment on if we were describing one distribution, right? So if I just said describe the distribution of household sizes in 1950, or describe the distribution of household size in 2000, right? We would want to make sure we comment on some specific things. Those things being the shape, any outliers or any unusual features, nothing weird going on, I don't think here. The center, and so hopefully we realize, actually I take that back, pretend I never said anything, and then the spread. right? So we always want to comment on socks. All right. Before we jump right into the sock stuff, a few general notes about comparing distributions, few helpful hints. I'm going to start down here. So I want to start with the bottom, which makes no sense because if I wanted to start with this, why would I put it on the bottom? Like, I'm the person who made this slideshow. Yeah, I don't know. I got nothing. Anyways, the number one thing to avoid, a fairly common thing that happens with students, and this is devastating because it shows me they understand a bunch of stuff but then get no points, is do not write two separate descriptions of socks. That is not a comparison. So if we're asked to compare distributions, right? If I write a description of sock, shape, outlier, center, spread for 1950, period. And then below it, next to it, whatever, if I continue. Then I write a description of socks for household sizes in 2000. Even if all of that information is correct, even if I've separately correctly described the shape, the center, the spread, unusual stuff if it exists, I'm not getting any points because that's not a comparison, right? That's two separate descriptions of two separate things. So to avoid that, it's extremely important that as we're working through this stuff, we use comparative language. We want to use words like bigger or smaller, higher or lower. Maybe we talk about a range being more wider or more narrow. So it's really, really important that we use our comparative language. Now, sometimes it's hard to use comparative language with the shape. Like if one thing's skewed right and one thing's unimodal and symmetric, then like you can't really use comparative language there. Even sometimes with outliers, like maybe you're just saying like, it doesn't look like either have any outliers. Or sometimes maybe we can say this distribution, whatever, has more outliers than the other. But oftentimes the comparative language is tricky with those things. So the comparative language I really want to emphasize as we focus on the center and the spread. Now, what measures of center and spread we use, right, is dependent upon what information we're given. So thinking to yourself here, we're given histograms. What measure of center are we going to use? What's really our only measure of center we're going to use if we're given a histogram? Sure. Now, hopefully we realize that actually you could reproduce the entire data set, right? Because going back to this, we know that, for instance, in 2000, there were 61s. There were like 105 twos and so on. So theoretically, I could put like 500 numbers in my calculator and get the mean and the median. But like, no, we're not going to do that. We're taking a timed AP exam. That would be ridiculous. So instead, we're going to estimate the median. For spread, similarly, we kind of have one efficient option. What do you guys think that is? Range. If you guys can't tell, there's actually not anyone in here. I'm just alone in my garage. But anyways, we could try to visually estimate the IQR, but it's honestly like not worth our time. We can, in this situation, we can calculate the range exactly because we can identify the max and min, and then we've addressed the spread. So there's really, there's no upside, I would say, to trying to take more time to estimate the IQR. So comparative language, you'll see that come up most often, always, I should say, with center and spread. Sometimes we can do it with shape and stuff. The last thing I want to point out is as we're comparing, right, you may or may not use the numbers when you're comparing center and spread. So it's not about the numbers, it's about the comparative language. So for instance, let's say someone writes the median household size in 1950 is 5. The median household size in 2000 is 3. Now, even if that person, even if those are the correct medians, right? That person, although they've given the correct medians for 1950 and 2000, they didn't compare anything. So sure, you gave me the right medians, you gave me the numbers, but there was no comparative language, right? So the median household size in 1950 is 5, the median household size in 2000 is 3, no comparison. That's not good enough. We want to compare. Whereas if someone says the median household size in 1950 is larger than the median household size in 2000, even though that person didn't identify the medians, they've compared, right? They've told us, they've stated which median is higher. And that is going to be enough for essentially correct. So that's what I mean by you may or may not use the numbers. And of course, you could say the median household size of 5 in 1950 is greater than the median household size of 3 in 2000, right? We could include the numbers. But the point is, it's not about the values, it's about the comparison in this situation. Another little piece, and you'll see this come up as we start to write. So here, right, just again, that center and spread comparative language. But I always then like to add a this suggests. So if we're going to state one median is higher than another, what does that suggest to us about the context? So we might say the median, you know, actually, you know what, I'll just wait till we get to that sentence. And similarly, if we say one group has a larger range than another, what does that tell us about the context? So I really like to go like with a dash, this suggests element in our sentences, because that really helps to hammer the context and ultimately kind of gets at the general statements. So we'll see that stuff happen coming up soon. So now, let's do it. So here are our two histograms. As we know, we've got to comment on 4 things, right? So we've got shape, we've got outliers, or anything unusual features like a gap or something crazy. I guess that's not that crazy. The center, which if we're given a histogram, we're going to try to estimate the median. I kind of wish I didn't, you know, write that down. At least it would have made you think about it a little bit. And then we're going to look at the spread. So your job right now is to pause this video and try to jot down some bullets. Don't worry about writing out a perfect description right now. Let's just kind of brainstorm. You know, give yourself a bullet. What's up with each shape? Describe the shape of each. Kind of give a bullet. Are there outliers? For the center, maybe you start to think about the medians of each. Maybe you estimate the median of each. Maybe you think about which median's higher, and then same idea for spread. So pause and kind of just come up with a bulleted list, and these are the elements we'll put together into our writing coming up. Pause. See, you didn't pause it yet, so pause it. Seriously, do it. And then come on, man, brainstorm. That's how we engage in these videos. All right, hopefully you've unpaused. And as you have done that, hopefully you told me for shape, as we look at both of these, right? These are both skewed right and unimodal. So both unimodal and skewed right. Both unimodal, not good enough for the shape. It's really the skewed right, right? That's the kind of the key distinguishing characteristic. Like if I told you a distribution's unimodal, right? There were no pictures, and I said, hey, draw a graph that's unimodal. You could draw like a lot, right? You could draw a bell curve, something skewed right, skewed left. But if I say, hey, draw a distribution that's skewed right, you're going to draw exactly what I'm, you know, that same shape. So the skewed right is the more defining characteristic of the shape. Now here in this situation, this is one example where maybe we could use comparative language. If, you know, with the shape, we could say that the 2000 distribution is more sharply skewed, right? There's kind of, right, there's kind of more of a steeper drop off here, whereas this is a little more gradual, a little more spread out. So this is more sharply skewed. So this is a situation where we might use a little comparative language with shape. Outliers, it doesn't look like there are any. Remember, we didn't calculate the fences, so we're not going to make any definitive statements about outliers. We're not going to say there are no outliers because we don't know that. Maybe this 14 here in 1950 is an outlier. But for right now, we could say there's no apparent outliers, or you could literally write, it doesn't look like there are outliers. But it's important that we don't make a definite statement because we have not done the math, calculated the fences to support any kind of definite statement. For the spread, right? For the spread for each, we're talking about the range. I skipped center because I got the next screen. I'm prepared for that. So for the range, so for 1950 on the left side, right? We've got a max of 14 people in a household and a min of 1. So for 1950, we're going to have a range of 13 people in a household, right? 14 minus 1. And then for 2000, we've got a max of 12 and a min of 1. So we have a range of 11. Whoops, that's not what I meant to do. It's 11, which came from 12 minus 1, right? I got to make it look the same as this. Right, our minimum is going to be 1. We can't have a min of 0 because you can't have a household. They probably didn't survey any households that were empty because, like, if they did, we wouldn't answer the survey. Or I guess they could just show up and like ring the doorbell and then no one answers, and like they do that, I guess, all day, and like I don't know, for a month, and it turns out no one's lived there. And yeah, that's a waste of time. I'm just gonna move on. All right, back to the center, the median. So here, before we even jump into the median, it is a few comments. As I started doing this, as I started trying to estimate the median, right? So we know the sample size for both years is 500, right? So I'm thinking here, all right, I want to do a little n+1/2 action, right? So I'm going to have 501/2, which gives me 250.5. And of course, that's not the median because that would be an insane amount of people in a household. But that tells us that the median, 250.5, is between the 250th and the 251st data value. So now I'm thinking to myself, like, all right, I want to figure out where are the, Where are the 250th and 251st data values? So as I was doing that, I'm starting to label these heights. It's really easy to get caught up wasting way too much time estimating these heights. So I like had the line thing out and I'm like trying to see what the heights were. And then I realized no one can do that on the AP exam. That's a terrible strategy. So one thing here is if you were going to do this, you want to try to estimate these really quickly and not over stress it. You know, if we take 10 minutes listing all these blue frequencies that I've pre-prepared, you know, like time's up. And then we just like didn't even write an answer and got a 0. So a couple things. So one, if you are going to estimate these heights, do it quickly. And as a matter of fact, these don't even add up to 500 when I double check. They add up to 505. And like part of me, the OCD part, really wanted to go back and try to fix it and make it add up to 500, but I don't have time for that in the AP exam. Same thing over here. Like these don't even add up to 500. I think these added up to 510, right? That's not right. That means these are off by a little bit, but like it's close, right? So I'm not going to stress about that because I don't have time on the exam. So if we're going to label those heights, kind of do it quickly. The second thing I want to point out though is I think it's possible. Remember, we don't need the numbers. So we don't actually need the exact, you know, the median of 1950 and 2000. We just need to have a pretty good idea which one's higher. And I think that we can probably determine that just looking at the graph. So here, right, like we're trying to cut the data in half. So here, this 2000 data set is like more condensed in the lower numbers. So to cut this in half, you know, we're probably thinking, I don't know, somewhere around here-ish. So the median, right, is probably somewhere around maybe 3 or 4. Or if I look at the majority of the data, right, like most of the data is here between like 1 and then maybe you'd say here, maybe you'd say here, either way, but it's between like 1 and either 5 or 6-ish, right? That's where most of the data is. I was going to start to color all this, but that's a terrible idea. Whereas over in 1950, did I just call it 1950? That's 2000, I'm sorry. Whereas over in 1950, right, this chunk is like more spread out. So 2000, the data is really clustered in the lower values, whereas in 1950, it's a little more spread out, which is going to raise that median if we want to find the middle. Like here, if I want to cut this in half, maybe I'm thinking, I don't know, somewhere around here, maybe around 6-ish, maybe around 5-ish. Those are like pretty bad lines. So, right, probably somewhere around this 5 area, right? Somewhere around here, we're cutting the bins in the bins in half. Or maybe I just kind of think most of the data is going from like 1-ish or 2-ish, but all the way up to like, I don't know, 8-ish or 9-ish, right? So this is more spread out here, this chunk, than this yellow one is. And so we probably feel pretty confident that the middle in 1950 is a little bit higher than that of 2000. I think it's reasonable to eyeball these graphs and arrive at the conclusion that the median in 1950 is larger. So that's definitely an option. It is. But going back to the beginning method in blue, right? I know some of us hardcore math people, right? We want to be sure. Some of us don't feel comfortable with that eyeball stuff. So we got to find the 250th and 251st data values. So over here, right, like from here to here, this would be the first 3 bins. That would be my first 100 data values, right? 5 plus 35 plus 60. And then from here to here, that would be my first 195 data values, right? 5 plus 35 plus 60 plus 95. I need to get to the 250th and 251st data values. But then from here to here, sorry, I was a little off. Make it up for me. Right, that's our first 285 data values, 5 plus 35 plus 60 plus 95 plus 90. So if we're going from 195 to 285, that means 250 and 251 had to be in this bin. And so we arrive at the conclusion that the median for 1950 is not equal to, because I'm not positive, so I'm going to say about 5. Whereas over here in 2000, let's do a little pink action. From here to here, like these first 2 bins, right? That's our first 165 data values. This is 60 that's covered up, and this is a sloppy 105. or from here to the end of the third bin, right? 1, 2, 3 bins, the one I scribbled it in yellow. That's our first, that's a 90, 100 and, 255 data values. Well, if we went from, right, this was the first, sorry, hold on a second. Get out of here, yellow. Get out of here. All right, so anyway, sorry. So if our first 165 data values, that was also like a pretty bad color choice, huh? I'll just go with some red. If the first 165 values are from here to here, right? 160 plus 165, and then from here to here takes us all the way up to 255, that means the median had to be in this bin. And so we end up with the median in 2000 is about 3. Now, I'm not positive about that because I'm not sure I estimated these heights that great. So like maybe it's like 3 or 4, or maybe over here it's like 5 or 6 or something. Either way, I'm not stressing about the numbers because I feel pretty good about saying that the median in 1950 is larger than that of 2000. So you got to really think about how to be efficient, especially with the center in this situation. Now we just got to put it all together and write it up. And hopefully when I get to the last sentence, my laptop won't die like when I was making this video earlier. And then I didn't want to. I threw kind of a tantrum. I'm not going to lie. I was like pretty frustrated. But anyways, here we are. So let's write it up. Let's put it all together. Let me take a peek here. What do I do for red, green, blue, purple? Got a color code, man. Got to keep my colors consistent. One thing I want to do also, did I do it? No. One great strategy for context is to always reword the context in the question. So I'm just going to literally reword the question. So I'm going to steal this for a second, right? We want to compare the distributions of household size in the metropolitan area for the years 1950 and 2000. So I'm going to start literally by saying the distributions, what did I do? Distributions of household size in the metropolitan area for the years 1950 and 2000, right? I literally just copied this wording that we're seeing down here. So that's a great strategy. Don't be lazy. That's a great strategy because we always need context in our answer. So now I've started immediately with some context, right? There's no way this answer will have no context if I start by rewording the question. So that's my advice. So the distributions of household size, metropolitan area for years 1950 to 2000. So now you don't have to go in order. You don't have to write shape, outlier, center spread, but I'm sure a lot of us like to. So I'm going to say are both skewed right. Start with shape, right? We said are both skewed right. Now in italics over here, I'm going to put, we could say that the distribution for 2000 is more sharply skewed. So we can use a little bit of comparative language with the shape in this situation. But, you know, if we didn't have what's in italics, like we'd still be able to get a perfect score. Again, remember that comparative language, we're really going to hammer it with the center and spread. So I'm pulling that in italics because you may or may not write that. So there's our shape. As we start to think about this, continuing, so green and blue. So for outliers, if there are no outliers or unusual features, you don't have to write about them. So this is also going to be italicized because you might not write this. But many of us, I know, at least I do, I like to mentally go through that SOX checklist. So a lot of students oftentimes still want to say there don't appear to be outliers in either year. Now, as we say this, right, we can't say there aren't outliers because we don't definitively know that. We did not calculate the fences. We also don't need to write what's in green because if there aren't any, we don't have to comment. And if there are no gaps, we don't have to write about gaps. We don't have to say there are no gaps in the household sizes for either year. But again, right, a lot of us like to go through that checklist. So next up, now we get our center. So here, we want to talk about our medians. What happened to my blue? So we want to say the median household size in 1950 is larger than the median size in 2000. It's all about that comparative language. And here you can see what I was referencing earlier. I did not use any numbers. I could say the median household size of 5 in 1950, ooh, f of 5, the good old algebra days, is larger than the median size, right, of 3 or 4 in 2000. But again, I don't need these numbers. So we'll throw those in italics because that's kind of optional. It's all about the comparative language. Now, here's where something new comes in. I like to add a this suggests. What does it suggest to us? What does it tell us about household sizes if we're saying the median in 1950 is larger? We really like to do this. I think this is a great idea because this is really going to help us hammer the context. Right now, we're not just talking about like generic things like the median of one data set's bigger than the other. Like, so what? What does that mean? Well, remember, a measure of center, we're attempting to represent a typical value. We're trying to represent a full data set with one number, which of course doesn't always work, right? But this is a typical value. So I like to use that word. This suggests that household sizes in 1950 typically were larger than in 2000. Or maybe you would say like, this suggests the typical household in 1950 was larger than that of 2000 or something. The word typical is important though, so we want to emphasize that because we don't want to just say households in 1950 were larger than 2000. That's not necessarily true. Not every household in 1950 is larger than every household in 2000, right? I can find a household in 1950 with 1 and a household in 1950 with 12. So that's typically true, right? That's what the median is telling us. Other thing we want to point out, right, is that comparative language, right? So we're talking about the median is larger. That means household sizes were larger. So this suggests element really gets at the context and it really hammers that comparison. So we're going to look at the same thing with spread. And so for spread, also, of course, side note, if you said the median household size of 2000 was smaller than that of 1950, typically households in 2000 are smaller, right? Of course, that's fine as well. So lastly, we want to talk about spread. So we can say that, why do I keep doing that? The range of household sizes is larger or wider, whichever one you want to use, for 1950 than for 2000. And again, right, I didn't use the numbers. We can, right? The range of household sizes is wider for 1950. In 1950, that range was 13. And in 2000, that range was 11, right? 12 minus 1. So we could add the numbers, we might not. But again, what does that suggest? And so here, there's this is the newest piece maybe of this. So when we're looking at measures of spread are are informing us. They're not talking us. That doesn't mean anything. They're informing us about the variability in a data set or the consistency or lack thereof consistency. So the fact that the household sizes have a wider range in 1950 tells us, or this suggests, right? I like that structure because it just kind of helps me remember it, that sizes varied more in 1950 than in 2000. Right? There was a wider range in 1950 than in 2000. Now, this suggests, right, one has a higher range than another, right? It doesn't mean anything to someone who doesn't understand statistics. That second piece, that this suggests, that means something to any person, whether they know stats or not, right? Household sizes varied more in 1950 than 2000. Or another way you could say that is you could say household sizes were more consistent in 2000 than 1950, right? Varied more means less consistent, right? Consistent is less varied. More varied is not consistent. That was like a pretty bad way to say that, but I think you know what I mean, right? Varied more, less consistent. And I think that's it. A lot of times I like to add like a general statement. So I might add something like this. I'll throw it in italics, but what's in black and blue and green and all that stuff up there, right? We have an essentially correct answer right here. So I might say like generally households were larger in 1950 in this metropolitan area. I might say that. I've kind of already said that by comparing the medians. So I don't really think it's critical that we have this last statement, but you know, whatever. Like now we're talking about the context, right? That's generally what the case is. right? So all the italicized stuff is kind of optional. So that's pretty much it. So we're going to do a little practice. At least my class is coming up soon. But to wrap up here, let's just take a quick peek and see how we did here. So looking at this rubric, this is scored in 4 sections. So essentially correct part 1, correctly compare center or location. We did. We compared which one had the larger median. Question 2, correctly compares variability. We did. We compared the ranges. We compared the spread. Section 3 includes context. We nailed that because we reworded the question and we added the this suggests. Those are really 3 good pieces of context, right? Just kind of introing the context, but then really interpreting the meanings of median, of the comparison of medians and ranges in context. So we really hit the context and we correctly identified the shapes. And this is a part we didn't do. So we nailed it. We're essentially correct in all 3 sections. And, you know, give yourself a high five or something. All right. Peace out, yo. I'm still here.